we have conquered the most difficult parts. The most difficult parts is salt hydrolysis and buffer. Okay. So these are the toughest parts, and usually they carry a lot of marks. So you must be able to do them. If you cannot do them, you are not giving yourself a chance. Okay. And if you are not following the calculations that I'm doing, that means that your foundation is very weak. Okay. So if you still cannot follow, what I need you to do is to go back and look at the notes. Go and find out the principles of, how a weak acid works, how a strong acid works. Find out how salt hydrolysis happens. What are the principles behind this? You also need to find out how a buffer works. Then after that, you come back and you watch this video again. And then you realize that it's much, much clearer. Because if your foundation is weak, right, you cannot understand the things that I'm doing. Then it will just make you feel like, wow, shit, I'm damn confused. Okay. So your foundation must be solid, right? It's like if I'm teaching you English, right? I want to teach you a fancy word, like maybe like, I don't know, potato, right? The potato is a fancy word, right? Yeah. If I want to say that, then you must at least understand what the alphabets are, right? You must learn ABC first before you conquer the word called potato. So it's the same, okay? Do your homework, yeah? Study your foundation. Okay, so we're going to talk about the last region, and the last region is very simple. The last region is called the excess region. So for example, they are going to ask you to calculate the pH of the 30 cm cube here. Okay, what is the pH when it's 30 cm cube? This is called the excess region because this is not the complete neutralization. This is also not a buffer. This is anything else. Yeah. So anything else, it's called the excess region. Let me show you why. Okay, so I hope you pick up the skill of how to approach an acid base or a titration curve. And the way I approach is always by writing the neutralization equation. By writing the neutralization equation, it gives you a sense of direction. Okay, and it gives you a structure for you to think. That is the most important technique. Most of the time we go into it, right, and we just want to anyhow whack, and then you don't know what you're doing anymore after a while. So please, go and write the neutralization equation. Go and write the ICE. Don't say it's time consuming. Don't say you are better than this. It's like, just do it. It helps to keep your working clean, neat, tidy, and it prevents careless mistakes. This is the most powerful method you can do this. Okay, so we are going to put in the values. Ethanoic acid is always going to start out at 0.0025. At 30 cm cube, we are going to calculate how many moles of NaOH that is. So remember, it's 30 cm cube at 0.1 moles per dm cube. So I will calculate that, and that will give us 0.0030. And you can immediately see that ethanoic is now the limiting reagent. So now the ethanoic acid is going to react. And that means this is minus 0.0025, minus 0.0025, plus 0.0025. No more acid. The only thing you have left is the base and the salt. Now, guys, the mistake that people make here is that they will go and perform salt hydrolysis here. You only do salt hydrolysis when the acid and base are zero. The base is not zero. This is not salt hydrolysis. Even though there is a salt that can go through salt hydrolysis, the strong base is inside the mixture. And the strong base will dominate the pH. Meaning, as long as there is the strong base in the solution, you don't need to do salt hydrolysis. All you need to do is to pretend that this is a solution of the strong base. Now, NaOH is a strong base, right? Which means NaOH will fully dissociate. So all of the NaOH will become Na plus and OH minus, which means that if you are trying to find the pH, you need the OH minus concentration, which will be equal to the NaOH concentration. And you can find what is the NaOH concentration by taking the moles and dividing it by the total volume, which is 25 cm cube of the original ethanoic acid plus the 30 cm cube of NaOH added. Convert them to dm cube. Then you calculate this, I think you'll get 0.090, blah, 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 blah. I cannot remember what the number is. But if you put it into the POH, you should get 2 point something. And subsequently, when you put it back into the pH plus POH formula, and you solve, your pH will get 12. Okay. So that is how you do excess region. Okay, so the excess region is basically a region that is none of the above. It is not a buffer. It is not a soft hydrolysis. It is not the initial point. Okay, so this region over here, the pH is 12. Okay, guys, so these are the 4 major regions. Okay, so let me downsize and then point out what the 4 are. First region is the initial region. Initial region is the beginning of the titration curve. In the initial region, it is as if there is nothing being added. So initial regions are very, very easy. Therefore, in the exam, it's 1 mark. Second, equivalence point. Guys, equivalence point, I say many times throughout this video that equivalence point is a salt hydrolysis. So when they are asking you to calculate the pH at 25 cm³ or any point that where complete neutralization is occurring, you are supposed to do salt hydrolysis. This is very tedious. 2 ICE tables, 3 mark question. Okay. Third, buffer region. Buffer region is also quite a long calculation, but it's never as tedious as salt hydrolysis. So typically they will give you 2 marks. If they ask you to calculate what is the MBC, it's only 1 mark. Yeah. And the last region we have is your excess region. Okay, so the excess region is the region that we just went through. Usually a titration curve question will ask you to calculate 1, 2, 3, 4. And the last question is going to ask you to sketch the titration curve. So basically how I like to do it is as I solve the questions, I already am drawing the titration curve together with my calculation because it gives me a sense of guidance on how to approach a question. Okay, so if you made it all the way until here, that's very good for you. Please make sure you practice. There are questions in my tutorial, page 13, page 17. You should go and practice them because they are not exactly the same as these are. They are slightly different. Okay, so I need you guys to go and use your brain and then try to apply. Okay, so good job for making to the end of the video. I'll see you soon. Bye.